So one of the first questions or comments I would say is from Benham. So I believe this was for slide 12, according to my notes. He mentioned that you need within study subgroup data to run this analysis. Maybe you can comment on that.
Yes, you do. You need the estimate. So maybe I'll show maybe here. If I just get rid of this just to show, maybe you need this exactly the same information you need. So an estimate. These are the same 5 trials. Here we have an estimate in subgroup 1 within that trial. Here we have an estimate of subgroup 2 within that trial. So you need exactly that information, but this is exactly the same information you need to the subgroup first approach, the current approach. So if you don't have that information, you can't do this method, but you can't do the other method. And we've had quite a lot of success actually contacting authors to get this information, for specific subgroups. So, we found over the last, 10 or so years, especially the last 5 years when I've been working here, that we've had real good success with collaborating with trialists and getting this key subgroup information, because for them, they can't, as I said, they can't really look at this reliably. So they want to know the answer to this. So if we can all work together, we can often find we can get this data.
Wonderful. Thank you, Peter. So there is one more comment or two more comments from Christopher Rose. So one says, thanks for a nice talk. Trials typically report effects for lots of subgroups, and the number of subgroups or those that are reported on and their definitions can vary meaningfully between trials. How do you think we should handle this?
Yeah, it's tough. It's tricky. Say you're just using published data and I don't know, let's say we use disease severity again, because I've been using it today. One is low and high, one is low, medium, and high. How do you try and harmonize that data together? And I guess I would just say we have had success with doing this in our prostate cancer studies, where they report number of metastases and people have different categories, and we've collapsed them together. But again, just contacting authors, and often if you collaborate with them, we found that they will be prepared to give you harmonized definitions across the board. In this COVID example I just really briefly touched upon, where was it? It was just here. I didn't really talk about it in any detail, but this actually used pre-publication data. So we actually did something called a prospective meta-analysis, where we got all the trialists on board as part of a collaborative group, and actually got harmonized subgroup data defined in the same way across all trials. But yeah, it's not always possible, especially if you're just using published data. But yeah, I would my experience is contacting authors has been fairly successful, at least in the reviews I've been involved in.
Thank you, Peter. And that's always the challenge, I would say, with meta-analysis. And a second comment from Christopher. You've considered 2-arm trials so far, but it looks like this approach could be extended to network meta-analysis to provide information about transitivity. Have you done any work on this?
We've started thinking about translating it into network meta-analysis. That's not something I've been directly involved in so much as of yet. I think we've found, you can do maybe a meta-analysis of the interaction estimates themselves, which could be quite interesting and nice. Getting the subgroup effects is another layer is another challenge. I haven't thought about it in terms of transitivity. This is an area, moving to network meta-analysis, that we're really keen to look into next. But yeah, I think there'll be quite a lot of complexities. But yeah, it's not something that I can talk to that much now. But yeah, I hope in the next few years we can extend some of these ideas, because obviously, you need the same information in network meta-analysis. And at the moment, if the network meta-analysis is just split by subgroup, so you do one network meta-analysis for low, and one for high, that's surely introducing a lot of bias. So yeah, I think it's really important, but I don't have an answer yet for you, unfortunately. But hopefully, watch your space.
Thank you, Peter. And that would be great if we could extend that. Okay, so Martin says, great work with this framework. Seems like a good step forward in estimating subgroup effects. One question, if there is any risk of bias for the outcome of interest in the trials, and this bias might lead to different magnitudes of effect in different subgroups of participants, which can be argued is quite common, Would any subgroup effect estimated from this framework not be correct to interpret as a true subgroup effects caused by the actual intervention? Basically, does this framework need the assumption of no bias in the trials, which is quite uncommon in most fields?
I'm just thinking about the question. I don't think so. I think this is. I would argue this is the same as you would for main effects. I don't think there's anything different here from first thinking about it. Of course, you want to look at your risk of bias between studies, across studies, and that would inform what you're doing here. But I don't think there's anything extra here to think about in terms of risk of bias than you would normally. It may be if you find something, if you have some studies with high risk of bias, you do a sensitivity analysis restricting your whole interaction analyses, your whole within trial framework approach, just to the ones that aren't high risk of bias. But yeah, I don't think there's anything extra here. I think the overall effect magnitude could be exactly impacted in the same way, unless I'm missing the question. But yeah, I think it's a concern, but I don't think there's anything extra that's a concern here than it would be for our main effects. But good question.
So David Fisher says, fantastic talk. Well done, Pete. And he also has one more comment. The issue with network meta-analysis is a problem of multidimensionality. It's possible to write down a model, but we've not been able to implement it yet.
Yeah. I mean, as soon as you get to networks, everything gets far more complicated. So
absolutely. A lot of more details to consider. Okay, Christopher also says we can't randomize patients to subgroups. How should we think about how the causality of interactions? How should we consider the causality of interactions?
What do you mean by I know you can't say that, but randomizing patients to subgroups. I'm not sure I understand.
Yeah, maybe you can add more details here. Oh, David has his hand up. Maybe can we unmute Dario?
Hi there. Yeah, I'm sorry. I'm one of Pete's colleagues on this work. Just to make that clear, I think the question relates to because patients are randomized between into treatment arms, they're not randomized into subgroups. Therefore, although we can make make causal inferences on the treatment effect, we can't make causal inferences on subgroup effects. And I think that's absolutely correct. And again, this is an issue that has an equal impact on this method as with the subgroup first method. The only difference here is we're currently thinking about this in more detail, and this may or may not be the full picture. But I think what we're doing here with the correction for aggregation bias is that we're getting perhaps a tiny bit closer towards causality by removing one aspect of potential confounding, which comes from the differences across trials. So that's one way of thinking of the causality aspect, but obviously we're not actually we're not saying that our method is any different, is much different in terms of causality, but possibly it's slightly closer.
Thanks, David.
Wonderful. Thank you, David. Okay, so we have one more question here from Louise. Are you planning on writing some of this code to be incorporated into RMW for those users who are not used to Stata or R?
I mean, yeah, it'd be amazing to try and do some of these things. Well, next step is R, just because that's where we've got a bit more familiarity and it's quite widely used. But yeah, I mean, there's no point having great methods. There's no point having methods if no one can use them. So yeah, we'd certainly be looking to do this. And I think, if anybody out there is willing to help, we'd be very pleased to hear from you. So yeah, no, I mean, we ideally would put this in as many places as possible. But yeah, no immediate plans, but it is on the list of things to do.
Thank you, Peter. And Benham has a follow-up question. Any difference between your suggested approach and running random effects meta-regression using within study subgroup data?
Yes, I think so. I think that would introduce random effects meta-regression. Yeah, I think David may have comments. I think that would definitely introduce aggregation bias quite considerably.
Okay. And then Joanna, she says, thank you for this interesting presentation, Peter. Are there any instances when you might consider not using this method? And that was also one of my questions.
Good question. Yeah, definitely. I kind of touched on it earlier. It's these single subgroup studies. So all of this is obviously based on interaction. I just want to show an example here. Let me just show this slide and share this. This is, if I have time, hopefully, this is just a quick example of a case where I think we maybe shouldn't use this. So this is a meta-analysis where we have patients hospitalized with COVID-19. The intervention is corticosteroids, and the subgroup here is basically mechanical ventilation. So notice here, these top 3 trials are what I was talking about, single subgroup trials. All 3 of them only recruit IMV patients, okay? So now you can see that the interaction is only based on these 4 trials. And these 4 trials are all pretty small. Look, the recovery trial is 1,000 patients big. It's not contributing to that. So our method basically assumes that there is a group here that would have been seen if, so basically it assumes that the interaction applies to these as well. That's hard to justify when 80% of the data doesn't contribute to the interaction. So we basically say if the number of single subgroup trials is quite large, then definitely this is something to think about and look at, are there differences between the trials, or do they all look pretty similar? If there aren't big differences, maybe it's still okay to use. But if there are, then potentially not to use it. Just as a caveat though, the subgroup first approach isn't good here either, because this again is where there's massive amounts of aggregation bias coming in, because these are massive trials that are just going to one subgroup. So in this case, I think I would say there probably isn't any good approach. And actually subgroup analysis shouldn't be attempted when you haven't got within trial information available. I hope that answers that question okay.